So a few weeks ago, a couple of weeks, I don't know, I did this. This is an orbital simulation, and I was trying to show how you can do this without really much complexity. It's really actually quite simple. If I look at the source code, is it circle? It might be circle because I probably started live as a circle, didn't it? Orbit. Now I just want to check that I'm actually live. I do look like I'm live. Alive. Even. So, here we go. So what I did was I basically showed this. I don't seem to even using vectors here. It's like very explicitly written out. I mean, normally everybody uses vectors, don't they? Just bear with me a minute. So I've just noticed the way that this screen seems to get cut off about. You actually can't see the whole of. Oh. Alright, if you want to see the whole of Unity in there, and then I guess I can, well, I guess I can sort of move this. Should we put it there? Why not? So this thing that is basically, it's doing an orbit basically, like it's quite fast. But as the thing gets closer, it's moving more quickly, and then as it moves, and you know, it moves more slowly, and then we can change the initial positions of this. Sorry, I'm just reviewing the code here. I think I was talking about things like, I was showing how we used to do it, this kind of thing, even in assembler. And I think because I had it at some point, I was also looking at fixed point. In fact, this is doing that. Yes, that was it. This is doing this simulation in fixed point, simulated fixed point. But what I'm going to do is create a new file which I'm going to call embody.cs. And we'll go to more kind of I have two different ways that works depending on which editor I've opened it. Right, okay. So what I'm going to do is just create something called embody. I'm going to sort of do try to do the embody problem. Now, admittedly, yeah, normally when you're setting up things in Unity, you're going to try and sort of think in an object-orientated way, and then have every object calculating its own gravity. Because the embody problem is a similar thing to that, but it's where you have a number of different bodies that are all attracted towards each other. And the problem that you have if you try and use the object-orientated approach for this is that it's not very efficient, and it can be a little bit, well, you'll see. Should we try and do it that way first? Yes, we could, I suppose, because the problem is that the object needs to be able to refer to every other object. And so you could have every object in the scene try to refer to every object in the scene by having a loop. But this does mean that every object gets executed twice, I think. But we'll try. I'll just do that, and then because I'm sort of thinking about this in my head, But I mean, maybe it makes sense to actually show it. Now, if I want to be able to get that bottom of, oh, there it is. Put my head in the game here. I'm just going to just delete all of this. Actually, there's no point in saving any of it. I'm going to create a script that will make this object attracted to another object. I'll put 2 in the scene. How about that? I've got 2 spheres in here. And I'll put them at different sort of locations, like so. And I want them to be sort of attracted to each other. I want them to do code between each other, which then means I need to know where the other one is. So of course you could just do a kind of find object, I suppose, but I mean that's going to be really slow, because it would be searching the whole of the Unity scene to look for all objects, maybe with a certain tag. I mean, but yeah. Can you imagine if I had 1,000 of these objects? Is each object going to hold the list of all the other objects? So, in fact, I know it's about mathematics, but we're actually in a question of architecture here a little bit. I mean, this is just seems trivial, but it isn't. We've actually got some interesting design questions in terms of software design here. Because if I have 1,000 of these and they all need to see the gravitational attraction occurs between each object and every object in the scene. So this comes back to what I was saying about object-oriented programming. It's like, whose responsibility is it to do gravity? Is it the object's responsibility to do gravity? Do you really want to have every object in the scene have a list of every other object in the scene? It feels like you want to have kind of a central list. So in the end, you would move away from the model where gravity code is in every object, and you just have the gravity code in some other module that just looks at the whole scene. And very often this is the way that you want to go. But what I'll do is I'll keep things simple for now. Why don't I, you know what? Let's do this. I'll just go in public game object other. I mean, I can feel myself cringing already. Let's just do it this way. I mean, this is the way that you're kind of told to use Unity all the time, isn't it? N-body, right. And let's see where there's N-body. That's interesting. I've got N-body with a capital N here, but that looks like it became lowercase. Not sure why it did that. This all went all lowercase. That's a bit odd. N-body, like that. Okay. Yeah, because it needs to be named the same. This needs to be the same as the name of the script, so then I can drag it onto my 2 spheres. Now if I click on bring them closer together, if I click on a sphere, you can click on a sphere, click on another sphere, and we can see here we have this other. And so this again is, there's so many tutorials that will show you doing this. This is a horrible way of using Unity, in my opinion. It's just, it's easy, but actually it doesn't scale. And so prone to little mistakes, but let's just do it this way. This sphere is pointing to the other one. Let's make sure, you could make it point to itself. I mean, so when you're debugging that, you make it point to itself, and you wonder why you get a divide by 0, and all this rubbish, and then you're not being a programmer debugging anymore. You're trying to figure out what bit was dragged to the wrong bit in Unity. I really wish we'd focus more on programming, but let's see. So I've gone here, I click on this one and click on that one. That's it. So this is sphere pointing, sphere 1. That's cool. Let's just do a proper numbering scheme, maybe starting from 0 here, because you could imagine if I wanted to do 1,000 of these, I'd have to sit there hooking them all up myself. That's an example of not scaling. Yeah, so sphere 0 is connecting to sphere 1, and sphere 1 is connecting to sphere 0. We'll change it later, but I'll just do it that way for now. I suppose we could then look and say the behavior of the object is to look at the other object and move towards it. There we go. So I'm just going to do that first of all. So how would I make an object move towards another object? Maybe at a fixed speed. So in the update, and let's use the fixed update. Because that gets called at a steady rate no matter what the rendering rate is. So then I don't have to worry about variable time steps. There are issues that come about with that, but I'm going to ignore those for now. They need to do with smoothness. Anyway, so what I'm going to do is look at the other object. Now I've got this other game object here. So we go and want to find the vector between the two. I normally call that D, so I'll do say vector 3D equals transform position. Oh, yes, do I have to type transform position every blooming time? You know how annoying that is? I have to type transform position, transform. No, we don't need to do that. I'm going to do this instead. Vector 3 position get return transform dot position, and then we can add a setter for it. Transform dot position equals value, and this thing now means that I don't need to say transform every time. I can wrong thing. I can do just that, and our position is the same as transform position. So this is an interesting tip, because you can just then get rid of that whole transform all of that. Because transform along with public, you end up you might as well have a special macro on your keyboard just for transform. I don't know why people just don't do this. It took me a while before I did this. In fact, I went further, because then I say, well, it'd be annoying every single object that I have to do. I need to do this, right? I mean, it's like, so. Don't be afraid of programming. I think we've all become afraid of programming. There's nothing to tell you, say that you can't do this. This is totally illegal, what I'm about to do. I mean, please do this at home. Now I've created a class called monoBehaviorX, which derives from monoBehavior, and in it I've added this. Oh, you know what? We can make this public. I mean, if you really didn't want anything other than the class that derives from it to be able to have permission, but everything else not permission, I could make this protected. But, why? I could just make it public. Oh, and then here I just go and do monobehavior X. It's an extended version of monobehavior that gets rid of the need to say transform everywhere. And I find myself delighted by such things. So okay, so what I do is vector D position minus other dot position. Except I can't quite do that because that's just a game object. But why don't I just make it an n body instead? Well, you can do that. It's totally allowable. Although this would have broken my linkages, my linking point, whatever you want to call it, that Unity does, I think, or maybe not. Let's see if it handles it. Oh, the name position does not have. Why did that? Does not exist in the current context, so that actually didn't work. Postition, yes. Everybody needs to have a postition. Somebody can help you with your positioning. I hear that those are very popular with politicians. Yeah, so we've got position, other position, and it compiles. And I don't know if it had the intelligence. Oh, no, it didn't. It broke the link. Because I had to assign them as game objects, and it's not clever enough to figure out that what's happened is that the code has changed, but the link was still valid. So then you have to go back and you have to redo the links again. This is why, incidentally, I avoid making use of this kind of functionality of connecting objects using the inspector that everybody shows you how to do. Don't do it. I mean, I've done it in the past, and then I learned that it really is not worth it, because I'd like to be a programmer. You see, that's my ambition in life, is to be a programmer, not somebody dragging a mouse around all day. So anyway, now I've got these two things set up, I think, and they are n-body. So this is n-body here. So this one is going to be pointing at the other one. But now with my little trick here, I can just say position minus other position. I mean, this is so much more readable. That's the other thing that we're talking about programming. If you have to say this all day, it makes the code harder to read. The vector is transform.position minus transform.other position. So you intellectually have to handle this extra word, transform. And it increases the cognitive load, the strain on your brain. Now, totally unnecessary. No, nothing bad will happen if you do this. So vector 3, D, equals position minus other position. And now what I want to do is I'm going to have the objects move towards each other at a fixed rate. So if I want a fixed rate, then I need to change that vector from one to the other into a direction which, you know, we can use a normalized vector for, which means a vector of length 1. So of course, in you go and do, I'll call this n, and I'm writing it very explicitly here because normalize. So that's cool. But there's a bug in the normalize function in Unity. So I mean, no, there's a bug in if the thing is, if the vector is shorter than about that amount, it just returns a zero length vector. This can actually cause real problems. There's no reason for it to. I've talked about this before. But it's just another example of what happens when people are not being rigorous with mathematics. And everybody assumes that if you've got a package like Unity, the developers behind Unity just get this stuff right all the time. Everybody has blind faith in stuff, you know, they don't question it. But in fact, mistakes are made all the time. This one's a real corker. I'll make this the topic of something later, maybe, but it does mean that you can't calculate the normal of a triangle of about the size of a millimeter, because if you try to do that, you will end up with a normal before you normalize it, which is shorter than this length, and so then you will get a zero length vector. If you've ever had a problem in Unity where you imported a model and scaled a model or something like that, and it's turned itself completely black, it's like that. Take a gigantic, it's because of this. If you take like a huge building and then you scale it down so that you can put it on your desk, so it becomes about this size. Like take the Eiffel Tower, a model of the Eiffel Tower, and you scale it down to this size to be on your desk, and it will turn black. And the reason it will turn black is because it's calculating normals, and to calculate the normals on things that small, you're getting the pre-normalized length of the normals being less than this number, where there is a check inside the normalized function in Unity where if it gets smaller than that number, it just returns a zero length vector, and there is no mathematical justification for that at all. I've had arguments with people about this. Oh, they must be doing it for a reason, and it's just like, nope, it's just wrong. Okay. So this is a bit of a pain. So I tell you what we can do though, is we can write our own normalize function. So and I will do that. Well, where shall I put my normalize function? I suppose we could do an extension. Let's see if I can do extension from memory. Is what class. Class. I mean, without looking up the syntax, it's class extensions, and then we can in here. I think you do public static, and it's going to be I'm trying to remember the public static vector3, isn't it? Let's see if I get this right. This vector3 v. It's probably wrong. Oh, hang on. It doesn't. Oh, it seemed to accept that. I missed. Yes, there was an unrelated error. Let's see. Maybe. Oh no, it doesn't like this. Hang on. Access modifiers are not allowed on static constructors. Oh, yeah, because that's an error message that requires some decoding. Actually, the real problem is I didn't put the name of the function in there. So this is good normalize, as in not broken. Let's see if this works. Extension method must be defined in a non-static class, non-generic static class. Okay, I need to make the class static, and not all paths return a value. So and here I did normalized with an S instead of, it's like, I could just call it normalize with an S. Anyway, good normalized. Okay, we'll do it like that. So, but really what I want to do is have an accessor, because this is actually property. So, except you can't do extensions which are properties. Oh, you couldn't. I don't know. Maybe you can now. Let's see, because the standards change all the time. This is generally how I work. I go and say, well, what's the latest? Do we have this? So can we have extension methods? No, it's not extension methods. We want extension properties, but I don't think they're supported. Does C# have extension properties? And the answer will be C# 7 and 8 have seen this as proposal, but hasn't released yet. Because if there's an implementation, they want to make it. Okay, so the answer is I'm on C# 7, so not yet. So I can't I'm going to just literally have to use a function, so okay, not the end of the world. So this is instead of just do that. See, and there you go, all these fancy features, and in the end you're dragged back into just doing it the old-fashioned way. And so then we want to return this. So how do we normalize a vector? We divide a vector by its length. So I want to know its length. So of course you could do vector 3 magnitude, which is the same thing as its length. But I'm going to just do it explicitly because it's probably the quickest way. We want to return so you could do mathf square root of vx times vx plus vy times vy plus vz times vz, adding the squares of the sides of the triangle. Pythagoras. X squared, y squared, z squared. Take the square root. That would be the length. So you do, say, float d for the length equals that. There is a reason why I'm doing that explicitly. I mean, yeah, this is the same thing as saying vector 3 magnitude. Yeah, well, we'll get to that in a minute. Anyway, so what I can do then is return a new vector, which is v divided by d. So this is my new normalized function. This is one that actually works, as opposed to Unity's, which has in it, if d is less than 0.0001-ish, something like that, then return vector 3 0. And what the functionality is like. Mind you, they fix it with the documentation, because the documentation says that if the vector cannot be normalized, it will return a zero-length vector. So at that point, everybody seems to think that they've got their backsides covered, and the only problem is that, in fact, you can still normalize this vector even if it is this small or smaller. In fact, you can normalize any vector that is bigger than 0. So there's absolutely no need for it. Okay, and I'm just going to throw in something else as well, just while we're here. I'm going to show you what this really does, because the mathf square root is a wrapper around the call to math square root, which is the standard C# implementation of the square root function. So what actually happens under the hood here is drawn out explicitly. Double a equals float b equals float no, wait a minute, then we need to take the square root of this, right? So double, beg your pardon, s equals math.squirt, which nobody ever uses or talks about, but it's there, right? And you can do that with A, and then we need the answer as a float, equals float S. So in fact, when you're doing this math f.squirt, what it does is it's hilarious, really. I mean, what it does is it actually calls the math squirt function, square root function, that uses doubles, because the functions that Unity exposes with mathf are floats, but those don't exist in the standard C# implementation. It goes straight to doubles. Now, doubles being double precision floats and more precise floats, more precise than floats. And so you've got this unnecessary sort of conversion in there. Now, the funny thing is that you will look at this and say, okay, but surely this is a float, this is a float, this is a float, this is a float, and so we can go in here and do a float and keep it as a float, and then put the float into this square root. But then there will be an implicit conversion, as it will actually convert this float to a double, put it into the square root function, and then cast it back to a float to get it back afterwards. And this is all happening under the hood. But here's the thing, is that then you think, well, we don't need this line. We can just put this in here like that. Okay, and then, you know, we don't need all of this rubbish. I was just doing this just to show you, so you can see what's going on. Boom, boom. This will work. It will take those floats, it will do the calculation, calculate the square root using this function, which takes a double, so we're in double land, and then it will return a double, which gets cast back to a float, and then comes into it. Now here's the funny bit. All of that is calculated as doubles. So in actual fact, the first thing that this does is actually converts every single one of these to doubles first, you know, and so on. Because the C standard specifies that that's what it will do. If you're passing an expression with floats in it into a function that takes a double, the first thing it does is promote all of the parts of the expression to doubles, does the calculation as a double calculation, then pass it to the function. So I find that quite interesting, you know, because it's like you want your code to be fast, right? So if you want it to be fast, you should try and avoid having a double at all. In fact, really what you'd want to do is to not use the math square root function, but write your own that literally works only in floats. So maybe you can't do that because maybe that's not available on the floating point CPU. But if that's the case, you want to try and make sure probably that this whole thing is not calculated as doubles. It is calculated as floats, and then you pass the float into the square root function when you've got to do a bit of this casting, you know. Anyway, it's hilarious because you think you get around this by doing that and say, you know, and so you look at this and it's floats in, you do a square root function, you get back a float. Now under the hood, it's converted all of the arguments to, well, not here, but in the normalized function. It ends up converting them all to doubles, and it sends them through to the double square root function that has to cast it back. So yeah, I'm going into minutiae here because I feel like it today, but let's just do this properly then. So we might as well get rid of this wrapper. We don't need it. We can call the square root function ourselves, we can handle doubles because we're adults. So we can go and this is going to get converted into doubles. It's going to calculate that. We're going to get a double back. We need to tell the compiler that we intend to cast it back to a float because of the potential loss of precision. The compiler will complain. And there, you're done. And so this is the good normalized function, I hope. Let's just see if I get any compilers. I have one. The name math doesn't exist, and of course it doesn't, because I need to include a using system, and then I think it will work. See? You know, why not? So this is nice because it's not going to break when the two objects are really close to each other, which for a physics simulation might actually be an important thing. Now let's look at this. We're going to go this fixed. Yeah, we've got a vector from one object to the other object. We call that D, and now we have normalized it with all caveats involved. And now I want to move the object. This is going to be moving at 1 meter per fixed update. If I multiply it by the time dot fixed delta time, then I will have a movement rate. I will adjust the unit, so to speak. So I'll have a movement rate of 1 meter per second. So let's just writing out really explicitly so you can see what I'm doing. So if this is vector v, we're going to multiply our n by time dot fixed delta time, and that now gives me a vector. And I suppose we can just do position plus equal v, because I don't need to do transform anymore. And because I've done a set and a get here defined for this property, I should be able to do a plus equals. Are you complaining, compiler? There's no complaint. Let's play and see what happens. Let's play and see what happens. Let's play and see what happens. Now, there was some weirdness there. We're going like this. Oh, I've still got the circle script attached here. That's kind of interesting. Remove component. There we go. Is that true of both? Yes, it is. Let's just remove component. Stop them trying to orbit and stuff. So here we go. And we go. And so now they're moving away. Moving away from each other. So that's good now. Alrighty. Now I want them to move towards each other, so if I just sort of flip that around, or actually it's probably better than flipping it around. Let's make D the vector from, you know, where we are to where we want to go. That makes more sense. So that's the other position minus our position, shifting the frame of reference, the other positions, as if we are at the origin, is basically what happens. So this should make it go the right way around. They should approach each other. Now I don't have autoplay set up in this project, but I'm going to hit. Oh god, look at that! It's like I hit play, didn't I? Does it work? No. This is why I set up auto things. I hit play because it had to compile first, and while it's compiling, it didn't register that I hit play. You know, you can do a thing though that's in the latest version of Unity. If I pick this out, no, not there. It would be under project settings. There we go. And we can go into editor, and there's this enter play mode settings, enter play mode options. And so basically, don't reload the scene when you hit play, and don't reload the domain when you hit play. And This might cause issues, but frankly, I prefer that I can just hit play and it sort of just starts. I mean, you know, it's like, wow, we've waited 10 years for this, that you can hit play and it just starts. 10 years. Or if I'm going to do it the other way, it's important, I learned this from the best, that when you're doing the thumbs up thing, you've always got to have one thumb higher than the other. You know, Boris Johnson was probably trained on this. You know, why not? Because if they're equals, it looks like you're driving a car. You know, it's like. Anyway, I've got very random tonight. I'm not on anything, am I? No, I'm not. I'm totally not even alcohol. Nothing. I think I've just been in the house too long. I haven't left the house in days. I'm all right. It's kind of interesting though that they hit each other as they would, and now they sort of seemed content to move together, which is kind of odd. Why are they moving together? Wouldn't they fight? I mean, why don't they just stop? And they don't stop because of the thing called execution order. So, yes, execution order. There is a way of changing scripts so they can execute themselves in a different order, but as far as I know, that isn't really possible with two objects that have two different objects that have the same script. You can only change the execution order of the scripts. You can't sort of. I can't swap them around. If I was to swap them around, because you think it's doing one and then doing the other. With one that does the one that operates last is the one that functions, and so that's why it ends up moving in one direction. Is because who's moving? Who the hell's moving first? Does anybody know? I don't know. Can I swap them? No. I mean, I could physically swap them. Maybe I can. Oh, I've never tried this before. If I swap them here, does that go the other way? No, that doesn't change anything. Yes, it's annoying. Well, let's just ignore that. This is the kind of problem that goes away when you don't use this type of model, and you have a kind of a central thing that animates everybody. Oh, hi! Oversimplified. Hi, Grumpy Game Dev. How you doing? Just saw oversimplified. They are leapfrogging. Who's leapfrogging? Was that probably relevant to something I said about half an hour ago? Oh! Yes, they are leapfrogging, yes. I think so. Yes, yes. I mean, it's like you think about it. Well, they are. There's that as well. You're right. Because as they move like this, eventually they pass through each other. And so then you would expect it to do this. And it could. But I suspect that just because of the positioning of them, it's ended up doing that. I don't know. You're right. Let me see if I move this a very small amount. What happens? I don't know. Oh, look! Look at that. It's moving the other way. So execution order, I think, is also relevant. But more important than that is exactly the synchronization of these steps. Because if you think about it, whoop, it goes boom. We're moving a step every frame. I suppose I could show that by hitting pause, or rather single stepping. Well, if we can zoom in and watch. So in fact they've already but it's only working to the center. I know they're touching, but how big they are is irrelevant. It's the centers that are moving towards each other. So that's that. That's that. And you can see they're not right on top of each other. There's an offset. You're right. If they're exactly the same point, the normal will blow up. which would be the case at least with my correct normalized function. If you're using Unity's normalized function, it's far more complicated because you can get any of three things happening. You could get the right answer, you could get the wrong zero, or you can get not a number, not a number, not. Which is actually just I couldn't believe it when I saw that thing. Oh. And I had people telling me how I didn't understand floating point maths, and it's like, what are you trying to say? Don't you see this beard here? I know it's not that long yet. I need it. Yeah. Anyway, so okay. What does this tell us? It tells us a few things. One of them is it's the color of the beard. Is there anything wrong with this color? Are you saying like my beard is the wrong color? Do you know that I actually have a red beard? Not a lot of people know that. This is it's actually red. So I've got four colors. The no hair color, the sort of dark hair color, the grey color, the red color. There's still bits of red. There's still all this is red. All of that. Oh, yeah. I'm not entirely white yet. I mean, the biggest tragedy is the fact that I shaved off my beard all my life, until last year. Actually, I grew a beard last year. So the real tragedy is that I didn't have a beard until I'm in my 50s, and then I grow a beard to find out exactly how grey it is. I think it's kind of sad I didn't see it. I never experienced the full red beard thing. That's gone. That opportunity is. I suppose I could dye it. It's the way to greatness. Dyeing, apparently. Cling to that if you need to. I don't need to cling to anything anymore. It's just I honestly I couldn't give a damn. Yeah. It happens to the best of us. Grumpy game dev. Yeah, exactly. That's exactly my thoughts. I mean, I could have had all kinds of other exciting things happen in my life if I had just grown a beard sooner. Anyway, I've just sort of multiplied the speed. Oh, look at this compile time. Gosh, I just multiplied the speed by 5 just to make the point a bit clearer here. Donk, 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 donk. No, I haven't. I haven't seen that gentleman's beard. So, okay. Well, how about if I wanted to sort of just have them, I promise I'll get to the n-body problem soon. Just have them, instead of doing this, which always has this problem of they jump through each other, use a different algorithm where they ease. So when they're far apart, they move quickly, and then they get closer and closer, they slow down. And this is my favorite algorithm. It's my favorite easing algorithm. So of course, the first thing you do to implement something like this is that you go to the asset store and you look for something called, well, we can just search for it, you know, easy easer. I bet you there must be an easy easer. Oh, nobody's got any imagination these days. I call it ease. Ease function. Easer. There we go. What's this? Let's have a quick look at this. Coming soon. Easer allows you to visualize and edit custom easing functions such as curves and look, it's only 447. You know, you can just import this into your project. €4.47. It seems like it's a bargain. But what they don't tell you is that whenever you do this, you incur unknown quantities of technical debt, plus the fact that it's a whole package full of, well, let's have a look. Classes, easer.cs, easer data, easer, there are all these classes here, and then they're editor classes as well. And actually, admittedly though, this is quite small. It's kind of respectable size. I've done this before. I go to the asset store and look at something because I think, yeah, cool. Wouldn't it be nice if I had something that quickly allowed me to do blah? And you go and you search for it, and there's thing, and you need one tiny piece of functionality out of this thing, one tiny little tiny thing. And yeah, what happened there? It's like magic. You need a tiny little piece of functionality, but there's this big package, and it only costs, and you just import the whole thing in, and suddenly your compile time is shot right up, and you've got all kinds of other things that could cause conflicts in your project. And so I'm joking when I say go to the asset store. Close tab. Hey Mycon, how you doing? Oh, Massacre, how you doing? Cool. I'm just going to catch up with the chat a moment. I managed to experience the full redness of my beard before the grey took it away. Yeah, the last time I saw that, I was like less than 20 years old. Just take my money. Yeah, there's always someone looking to do that, Mycon. Yeah, that's how they get you, yeah. So, okay. No. Seriously. No, not seriously. Yes, seriously. I'm just kind of easing between serious and not serious, you see. What we've got is we want to do this easing thing. And so I'm going to forego going to the asset store, the first thing everybody thinks about, believe me. And instead I'm going to do this. I'm going to change this thing that I made so that I'm actually not going to use the normalize anymore. I'll comment that out just to indicate I'm not using it. And instead I'm going to use D. So basically what I'm saying is that the speed at which I move, it depends on the length of D. So the longer D is, maybe not multiplied by 5. We'll just give this a go and see how that is. And there it's compiling really slowly. And so there you are. I didn't have to spend €4.49. I have an ease. And this ease function is my favorite ease function ever. It's so useful. I have tried other eases, but then none of them work as well as this. This is just simple. In fact, you can see it's kind of chasing as I move this around. You can see how it works. And if I want to make it move a bit faster, I can just sort of scale this up. And this has this ease function, incidentally, has a lot of interesting properties, or has a useful property to it, which is that it's independent of distance. So if you use this kind of ease function to go a little way like this, or a huge way like this, it doesn't matter what the distance is. The time it takes for it to get approximately the same place is constant, regardless of the distance. So it's a very good quality. And even better than that, I actually implemented it removing a line of code. So there. -1 lines of code. Take that, asset store. So okay, right. Ease function. So what I'm going to do now is, you know, Mycon, that's exactly what I was thinking. You read my mind, and I was going, should I say that or not? And I decided not to, but it just goes to show that sometimes you don't have to say it yourself. It's quite all right not to say something, even if you're thinking about it, and then allow someone else. This is something that's taken me years, because I'm such a talker. It's taken me years to figure out. You don't always have to be the first person, Dino, to say it. Right. So anyway, to get back to this, what we have now is this thing where both objects are trying to move in towards each other, and that's fine. But what I want to do is set up an orbit, so that is, they orbit each other, right? So this is the two-body problem. So what I will do with that is I need to add some stuff, I think. So of course I'm going to carry on for now into the typical Unity way of thinking. You know, actually there is an argument that the mass of the object belongs quite nicely in the inspector. It might as well, come to think of it, I suppose. I mean, unless you have 1,000 of them, I'm not going to sit there and fill them all in. So then I'd probably have random distribution. I just have them filled in at random. But right now, I will have, you can specify the mass. So let's create one of these and call it mass. And then I'm going to just see if things compile. And if I click on this, I can then say this object's going to have a mass of 2, and this object is going to have a mass of 1. Now I'm just going to leave it like that for a minute. So now I've got a mass. Now, the mathematical formula for gravitational attraction. So here's paint, and it's blindingly white, and that's very annoying. So let's just, that's a bit better. And then we can probably do this, and there we go. So if you have two objects, like a sun and here's the sun and here's the earth, for example, or the earth and the moon, really doesn't matter. You want to figure out the orbit. Implemented dark mode for paint. Absolutely, that's what I did. Dark mode for paint. You saw it happen right there. Did involve an asset store. So what we can do is look at this vector between these two. In fact, actually, you know what I'll do? Let's look at this in 2 dimensions first of all, and we'll just study this problem a little bit. My mouse drawing skills, leave it locked. Oh, this is funny. This is hilarious. Microsoft. The eraser is black, so it cannot be seen. Right. And so what I'm going to do is put this here, and then we just, for the hell of it, make a right angle triangle. You can say, well, why would you want to do that? Well, it's because, you know, we have a coordinate system. So this right angle triangle always exists, as you know the coordinates of these 2 points. There's going to be some distance between the 2, which I will call r, because it's often called r, although in the code I'll probably call it d for distance, but yeah, so it's r. And we also know, well, we'll call this one object A, and this one is B. Okay, and we need to figure out a force of attraction between these two. So B is pulled towards A and A is pulled towards B. Now, the force that exists from the gravitational attraction of these two things, that is going to apply both ways. So whatever the force is acting in one direction, there's an equal and opposite force acting in the other direction. And so they both get pulled in towards each other. The force is going to be the same, but the acceleration won't be, because one of the objects is heavier than the other. So we go back to Newton's laws of motion. F equal ma. So if you have F equal ma, it therefore follows that acceleration is equal to force divided by mass. So the bigger the mass, the less acceleration you're going to have for the same force. So that's fine. We need to figure out what this is, though. We need to calculate this F. Now, F has been experimentally and theoretically demonstrated to be proportional to the inverse of the distance between the two, which was a lot of words, but basically means the closer two objects are together, the higher the gravitational attraction. And it falls away very rapidly to the square of the distance. We can say that F is proportional, that's what that means, to 1 over r squared. And this just leaves the question of how. What is the actual relationship? So, to make this an equal, we would actually need to do something else. We would need to say, to make this an equal, because the force isn't equal 1 over r squared in all cases, but in all cases you can say that F equals k over r squared, where k is some kind of constant. So the question now is what is that constant? Now, one of the things that you know is that when an object is heavier, more massive, right, it's heavier because it's harder to lift. It requires more force to lift it off the ground. Well, that force that is required to lift an object off the ground, that force depends on the gravitational attraction. Micon, yes. The fast inverse square is still relevant. You could use that as an approximation or use it as the first guess to speed up the calculation of square roots. So yes, that is relevant. The fast inverse square, but I think that was the fast inverse, not the fast inverse square. Actually, if you think about it, it was the fast inverse square root. And the reason why the fast inverse square root is important, I'm going to just go on to a different topic since you just brought that up, is to come back to the normalization of vectors. We'll see that again in a minute anyway. But if I have a triangle, like so, you want to understand, you want to figure out how to normalize this, how to normalize that, right? Well, as I showed you, you divide by the length of the vector. Well, dividing by the length of the vector is the square of this side plus the square of this side, right? And then you take the square root and you divide. When you take the square root and divide, that is the inverse square root. So if you have a fast inverse square root function, you can calculate the sum of the squares of the other two sides and then very quickly do 1 over the thing to give the amount that you have to scale your vector by to normalize it. So it basically, the relevance of the fast inverse, the famous fast inverse which is always credited to Carmack, which is rubbish, because nobody really knows who originated it. There are some theories, but it actually goes back to SGI. So, you know, it predates Carmack. And it really isn't even that strange, to be honest. It's one of those things, people see the magic number and they go, ooh, but if you get the magic number wrong, if you adjust the magic number, you just don't get so accurate a result. It just picked and they found a number that minimizes the amount of error. And the trick has just got to do with bit shifting, because in a way, when you do a bit shift, you're doing a kind of square root, or a logarithmic thing. And it's a cute hack for sure, but it's nowhere near as mysterious as it gets painted. Anyway, but the relevance of it was this. So these days it's not so important, because you know the floating point processors are blindingly fast. But back in the days where a square root was expensive, any speed up of the square root function for computer graphics was absolutely critical, because you want to be able to normalize vectors all the time. So there you've got your little history on that. Yeah, I know. I'm not saying Carmack. Yeah, no way was I saying. In no way was I saying that Carmack claimed that he did it, but people assign things to people. They create their own version of reality, you know. And yeah. So anyway, to get back to this, what you've got is the force acting on here. We've said it is proportional to some constant k divided by the square of the distance, which of course make you think, oh, then I don't need a square root. Well, as if only it was that easy. You still need a square root, but you can do an optimization to make sure that you don't calculate two square roots. You can just do the one. But anyway, I digress. So the point is, I was saying about masses. The more massive an object is, the harder it is to pick up. But that's because the bigger an object is, if you double the mass of an object, it has double the attraction. And that's what you see. And it's very easy to verify experimentally. One orange requires a certain amount of effort to lift, and you can measure the force required to lift it. Two oranges, identical oranges, are going to require double. And so this was very easy to verify. And of course, because of the fact that it's a mutual attraction, you can actually say it's relevant to both. That is, it's not just the mass of the orange, it's also the mass of the planet. And that's why when you go onto the moon, for example, there's lower gravity. There's a lower gravity because the planet is less massive. It's really easy. So we can actually say that, and I'll go back to the proportional notation until we've kind of completely fleshed this out. We can say that it's proportional to the mass of A times the mass of B. So this if I double either of these masses, I'll double my force. Okay. We're still not equal though, because I suppose there would be a certain set of units that we could invent where it would be equal. That would be different units of time and different time actually. Well, force, Newton meters per second. Yeah, time. Different units of everything. All the units would be different, but you could choose different kinds of scales of all our measurements to make this equal one. That isn't the way that it is. The reality is that you need some kind of scaling factor in there, and that is found experimentally, and it's given a capital letter G. So what you have is G, universal gravitational constant, which is thought to be the same everywhere in the universe, which is kind of weird. Of course, we have no way of knowing for sure that it's the same everywhere in the universe. So that's an assumption that's often made with mathematical theories. When you're trying to understand how the universe works, whether it's an expanding universe or a contracting universe or an exploding universe or whatever, you have to make certain assumptions, and one of the assumptions is the universal gravitational constant is universal. It might not be. I mean, how will we know? We can test it, and probably we have tested it on the Earth, and we have tested it on the Moon, and we probably tested it on Mars as well. You could say that with the paths of the planets, of the satellites that we've had in our solar system, we've proven that the gravitational constant is constant for our entire solar system. But that doesn't say anything about the next solar system, or the Andromeda galaxy, or any of the billions of galaxies that are out there. Who knows? So it's an assumption. But this is way beyond really what matters for us now, but I find it interesting. This gravitational constant has a number. You could look it up. Look it up in the book. But the thing is that really doesn't matter for this, because I'm not going to aim for realism. I'm going to aim, as in mathematical accuracy. I'm going to just want to get the shape, the pattern, the movement, the animation of, is all I'm interested in. And so for that reason, we can just pick any old value of g that works. Yes, because we're the gods of our own universe here. Let's go and just do that. I'm going to create the value g, which I will make equal 1. Might as well for now, to see what happens. And then we have the two masses. We need to know the distance, but we've got the distance squared, right? So I'm calling it d here, but we can say float. Well, let's call it r, because why not? So we call it r2. That's for r2d2. We could just make the distance squared here. So let's do it like this. There is square magnitude, I think, or is it magnitude squared? No. Oh, it's because it's a lowercase s. There we go. Yeah, there it is. I was almost right. So we got that is going to be the square of the magnitude of the vector from one to the other, or the square of the distance. So this is fine. I can use this to calculate this 1 over the r thing, this 1 over r squared. And I will just go straight into the force now, because I think I have enough to know what F is. The force is our gravitational constant g multiplied by our mass multiplied by the other mass divided by r2, which is r squared. And so now we have our force. Well, what we need to do with the force is actually work out an acceleration, and that acceleration is the force divided by the mass. So I'm going to just go and do that here. Float acceleration is equal force divided by mass. Now, when you look at this, you will see something interesting. That I have this formula here, and I divide it by mass. This will cancel out with that. I mean, in essence, what I'm saying is the acceleration is equal g m a m b over r squared divided by m a, and so these cancel. So what I could actually do is go straight to acceleration here by simply doing that. Makes sense. The other mass divided by r squared. Great. Now I have an acceleration, but the acceleration is not a vector. It's a scalar. It's a number. And so unfortunately, to turn it into a vector, I need the normalized vector between the 2 points. So I'm going to have to calculate the full length of the vector anyway. But because I've done the math here, I know that I can get away with only calculating the square root once. So if you do it naively, right, you could go and work out the distance between them by doing magnitude, and then you take the magnitude and square it, you know, and then you'll do a normalize, which contains a square root function. And so you end up, you know, it's like, just forget all of that. Do it like this instead. You know, you can make it run a little bit faster. I mean, not much, but it all counts. And in fact, for this algorithm, every little bit counts, because it's an n squared problem. It's like if you do 1,000 objects all attracting each other, you need to do 1,000,000 point-to-point calculations. So, in fact, every little bit counts here. So what I'm going to do is, for the normalize, because I do need it, this n, all I need to do is make this equal to d divided by the square root, and I'm going to use the math f despite what I've just been saying. But no, let's do it. The math dot square root of what? The square magnitude, which is R2. So if I do that, just clean my glasses. So if I do that, I've only need to calculate one square root, because I'm just normalizing the vector manually. And now, having done that, I can work out my acceleration vector, which I'll call capital A here, as being n, which is my normalized vector, multiplied by my little a. And so that gives me now the acceleration as a vector, which is great. The other thing you'll notice is I've done absolutely nothing about time. The fixed update time isn't in there, so my units are all over the place. I'm basically, this works only because I'm assuming the time step is 1. And what I will do is tweak the value of g to make it work. And you know, unless you're actually trying to do a real calculation of planets and orbits and so on, this is fine. Just, you know, point of order here, there is an implicit conversion of units making the assumption that the time step is 1. So and then we can say things like I need to change, well, I don't have velocity yet, so it might be an idea if I add a velocity. Vector 3, of course, I'm forgetting. You want to add velocity to your object. The first thing you do is you go to Unity, and then you select the object, and you go up to the menu here, and you go and add a rigid body. No, I know that's, you could also just do this. For this kind of thing anyway. I mean, there's obviously a reason for using the physics engine, but Unity's physics engine is overkill in this situation. Vector 3, velocity. Yeah, you would probably, that's an interesting question. That's a very good question, Nikon. Would you be able to make it go backwards? And the short answer is no. The long answer is maybe, but it's probably not entirely deterministic because of precision errors. The problem is that, well, the answer is yes. I'm sorry. The answer is yes for 2 bodies, maybe 3. I can't remember where it got solved. How many was it solved for? 3 body problem. Yeah. So as a fact, there's no actual closed form solution. There's no mathematical solution for 3 objects. So if you had 2, the answer is absolutely yes to your question, because you can go and specify functions that tell you exactly where things are at what time, and there's no state involved. So you can just ask a time and boom, there it is. But as soon as you have 3 or more, that isn't available. Then what you have to do is solve the equations of motion by using a numerical technique. And so the problem with numerical techniques is that they are then approximations in some form. And so you're probably not going to be guaranteed. You could probably do an approximation, you probably go back a little bit. If you're going to be clever, you could probably save the state and then use such approximations to interpolate between those states going backwards. There's all kinds of clever things that you could do, but the short answer to your question is yes for 2 objects or 1 around a stationary point, but no for 3 or more. So anyway, and I thought that was the case. I was just checking to see if somebody, if that had changed. You know, it's like, well, it was the case, there wasn't a solution, but somebody went and figured it out. No. It's probably proven that there is no solution at this point. So in any way, what we've got then is this acceleration vector, and so now I'm going to apply acceleration to velocity, which normally would require multiplying by time, but as I said, I'm assuming that time is 1. So we can say, and I just introduced a velocity, so the velocity plus equal acceleration, and then position plus equal velocity. And this is all great, isn't it? Can you spot the problem? We'll see if it works, but there are problems already with this. You know. Yeah, there are serious problems with it. And you know, you can argue serious problems because it's coming from thinking about things in an object-orientated way. It's like, it's an object. This is an object. They do things. Doesn't work. Yeah. But let's see what happens. Oh, we got an error. Where? Oh, I missed out a semicolon. We're going to try. Missed out a semicolon. Come on. Oh, what's the next one? The next error. We have an extra No, the semicolon was in the wrong place. You don't want to put your semicolons where they don't belong. And what's the problem now? The type name's vector 3. All right, and then I guess, of course, some kind of weird thing happens. So I don't know. It happened too fast. I mean, you can zoom out and try it. Who knows? All right. So what you know though is that you can reduce the size of G. Hey, a synchronous callback. Yes, I am. Sorry, that was a little joke there. But, I don't know if you saw what I did there. A synchronous callback. No. What we could do is, I'm terrible. I've never been this bad. Is make this number smaller, and then things move more slowly. I'm back. I've been back for a little while, but I do 2 shows a week at the moment. I can't. How's too much work? Well, who knows? I might bring him back at some point. Hal is still introducing things. Hal is on the radio. You want to hear Hal? Hal is on the radio. Radio Radion. R-A-D-I-O. R-A-D-I-O-N. I don't know if you could see what I did there. Why Radio Radion? Because you go radio, N, right? Radio, right? But Radion is Dion is also a anagram of Dino. Aha! More maths, I think. So, it moved a bit more slowly. We can just. This Radino is broken. Is it? Let me check. Radio Radion, bringing you high quality music, not focused on commerciality, 24/7. Come on, Hal. You never know, Hal might say something now.
Ever fancied yourself as a DJ? RadioRadion.com.
Oh, this is the best track ever. Look, Ray. Oh, yeah, tune in, everybody. We have a little radio break. "21st Century Schizoid Man." Yeah, anyway, you can listen to yourself. That's probably just one of the best tracks ever. That I love it to death. That, and it's so relevant. And the lyrics, nothing he's got he really needs. 21st Century Schizoid Man. Yeah. What's that? Iron Claw neurosurgeon scream for more. At paranoia's poison door. 21st Century Schizoid Man. Meanwhile, back to the mathematics. So what I've done is I made this smaller. And then we can see that something is happening. We're in fact moving towards each other. And then you can see that something sort of upsetting happens. It just kind of goes kaboom. And the kaboom thing is due to precision errors. When you get really, really close, I am wondering what will happen if you put in. I've been meaning to do this for a long time. Is to use the full equations of motion to see what happens with this case. If this ejection is due to integration errors, or if it would actually happen in some way. Because what's going on is that in this term, here is that as r gets smaller and smaller, so the force becomes really, really large, and it gets very, very small. The force becomes huge. But you see, it's quite interesting, because you'd say, well, why is it that we're standing on the planet and there's no bare feet and there's no gap between my feet and the planet, and I'm feeling it, man, you know, in my bare feet? But why? Why is the gravity not infinite? That's what I want to know. Well, there's no distance. I actually don't have a good answer to that one. But what happens is, there is an answer actually. What happens is that the whole of the Earth is attracting you, but some bits of the Earth are closer than others. So this bit of the Earth that you're on now is attracting you the most. If you're in the UK, over in Australia or New Zealand, stuff over there is also attracting you and me, right? But much less, because the distance is greater. But it turns out that if you sum all of the attracting bits of the entire planet where you are standing, it mathematically is proof for it, mathematically becomes identical to it being as if the entire mass of the planet was centered in the center of the planet, right? The whole mass was in a point. It's mathematically equivalent. But of course this means that you're not actually, therefore, at the center. You need to get to the center in order to make that distance become zero. But if you did go down there, you'd actually have a reverse gravity, because if you were actually in the middle of the planet Earth, all of the mass of the planet would be around you, pulling you in different directions, and in fact you would be floating. I mean, that isn't if, you know, making the assumption that you know, ignoring the fact that you'd actually be sort of eviscerated because of the molten magma core of the Earth. But you know, anyway. So yeah, it's quite interesting. It does, but there is this weird thing that because of the mathematical equations of it, you do get the slingshot effect. The core isn't molten, probably isn't, that's my ignorance. What is the core then? I kind of assumed it would be. Is it an iron core? Euroscretion. Iron core! Neurosurgeons scream from all. Yeah, I don't know. I'm not a geologist or much of an igist. So I've kind of completely stalled here. Where was I doing? Oh, right. Yes, I was looking at this. So the point being that in reality you will never get two things able to be on top of each other. So, but we're going to pretend that that isn't the case. We're going to ignore that. There is another thing we could try though, which makes me wonder. If we use a smaller gravitational force, I'm going to try this here. Shouldn't it? Yeah, it doesn't matter. You see, that's the weird thing. Is that even if I go and in theory, if you use smaller time steps, it's more precise. It doesn't change anything. So anyway, let's move on. So I'm going to go and put this to some value that makes things move sort of nicely. Is this? I keep expecting it to autoplay. Now, alright, one of these masses is bigger than the other, right? Which was this one's 2 times the mass of this one. What I'm going to do is give them an initial velocity, because right now the initial velocity is 0, which means that they will attract to each other, and then you'll end up with a situation where they're directly on top of each other and you get this weird case. But if I start this one off moving away from the planet, from the other one, I should be able to get some kind of orbit, and that will be the idea. So what I want is an initial velocity. Well, it turns out the velocity is already exposed, and so what I'll do is just put a gentle z velocity of 1 in here and just see what happens. Now I need much smaller speeds than that, I think. Yeah, this changed the behavior a little bit, but I would, oh, right, minus, because I need it to go in the opposite axis, and let's make it a bit bigger, and let's hit play. And there was a lot of talk, right, but in fact it was working. It just, we needed to set it up. I'm going to try increasing G. This will just make things move faster. Oh, yeah, it's very sensitive. I'm going to have to make it a bit smaller. I've got to tune it until eventually it looks nice. Nope. Let's halve it again. Try. And this is pleasing. It's unstable, and this is due to precision issues, probably more than anything. Although I know that it's going to be possible to, well, it could be precision. It could also just be that it's not a stable pattern. I've just made changed the gravitational constant, reduced it a little bit. Let's see what happens now. Just be nice if it just maintained its stability. I think we're there. Part of the issue, of course, is that the other planet, the planet was not moving and the initial setup, so it had to sort of get dragged along for it to settle down. But that seems to have happened, and this is now a stable. That looks pretty stable to me. That's cool. Oh, hang on. Oh, I spoke too soon. Oh no, what's going on? Why you? Whoa! Why did it do that? It shouldn't have done that. So I'm going to just check something, because it could be that we're thinking that it's all lying in a plane, but maybe they were shifting. It's like a discus thrower from above. Yeah. Well, it is what happens, because you've got the mass of the discus player. It's much bigger than the mass of the ball, or the thing that you swing on. So I'm a little bit perturbed about how that is unstable. But I know from previous experiments that I've done with this that as the two masses are closer in two masses are closer in mass, stability becomes harder for whatever reason. So I'm just going to try increasing the mass of the planet to 10 times. Yeah, I don't know what it's called either. So let's see. All right. So a little slingshotty thing. I'm going to reduce the gravitational constant a little. Hammer throw, yeah. Probably because originally it was a hammer. No. So at this point I'm beginning to wonder if there is a bug. Yes, there is a bug. There most certainly is a bug. And I thought about it earlier and I kind of warned the entire universe about this bug, and then I forgot about it. And now I've remembered it. There is a bug. And you could sit here and play with this and go, I think you're done. And then it's just nagging doubt in your mind, but in fact, there is an error. So I don't know if you can spot it, but it's one of those ones that's difficult to spot. So the problem is, it's not actually. I think the math is right here. This is normal. No. You can see it's almost working. The problem is that the position of one of these is being calculated before the other. So instead of calculating the whole thing for the positions of the two, one of these moves and then the other one gets calculated with the new position instead of the old position. And so this is introducing an error. It's a classic problem, classic mistake. What you actually need to do is go in two phases. The first phase is you calculate all the forces and then the accelerations, and then you apply the accelerations to the velocity, which are fine because the velocity is not an input into the formula, but the positions are an input to the formula. And so you need to make sure that you finish all the calculations for everybody before anybody moves, and then once that's finished, then you move them. And so here we are. We've done this in a very object-orientated way and fallen into a trap. And so this comes back to the thing I said right at the beginning of this broadcast. It's like I was thinking about this problem right from the start, going, well, how are we getting? So I deliberately did it this way just to show. It's like this is no good. This is no good because if I put this in the fixed update, so everybody's going to want to move their own thing each time. I guess I could do everything except this line. This is the line that causes the problem. I need to do this at the end. Now, there could be a cheap way of doing it. I suppose use a late update. But hang on a minute. The rate at which the fixed update is called is different from the late update. I would need to have a fixed update call that is made after all the updates, which I suppose I could do if I created an object, a script, a component, and I put it on an object, and I go and say the execution order of the thing is that gets executed at the end after everything else is done. But what a fracking nightmare. This is not programming anymore. That's it. This is the trap with Unities. You end up not programming. So I'm not doing any of that rubbish because I've tried it and it really doesn't work. Things go wrong. You lose sight of that. Somebody goes and drags the execution order by mistake with a mouse. This is not... no. And so then you go, we need a better way. And the better way is to actually put all of this calculation in a centralized place. And stop treating these things like little objects, because that's just like a nightmare. It isn't about objects. I'm very critical of object-orientated programming. I consider it to have been a huge mistake, and I know there's an increasing number of people who agree with me. But it's not about objects, it's about what you do. It's about verbs. So there are many ways of looking at the problem of object-orientated programming, but the one that I kind of gravitated to, that I find most, well, interesting at the very least, is this thing that object-oriented programming kind of tries to make you think of everything as a noun, because an object is a noun. But nouns are not what are interesting. Nouns are not what is important. It's not the things that are important. It's what you do with them that's important. The whole point of a programming language is to do stuff. So this attempt to try and nail things down as nouns instead of embracing the verb, and it's like a fear. It's a fear of doing. It's a fear of verbs. It becomes, and it translates eventually into a fear of programming. So people don't program anymore. They just embrace frameworks or get stuff off off an asset store or whatever, or copy and paste code. They try and avoid programming. This is the big problem with software engineering these days, is everybody's trying to avoid it. And it's like, no. And part of the problem is, I think, quite seriously, that you make an object. Everybody's trying to turn their verbs into nouns. That's why the word manager came out. The problem with the word manager as an object is that you're creating an object because a manager is a noun, but the manager manages, and so it's actually a verb dressed up as a noun that doesn't really tell you much about what it's doing either. It's like, let me know what it's doing. So what I need here is not a gravitational manager. What I need is gravity, actually. I need to do gravity. It's really tricky, because after a while, after a decade of wrestling with object-oriented programming, it's very difficult to remember to think in verbs. Anyway, I'll just check the chat. Object isn't the problem, it's the orientated that's the problem. Well, yeah, I mean, I would say it's because object is a noun and orientated is an adjective. So again, they've avoided verbs. I mean, it's sort of like, it would be better if they called it object doing. I had to use Unity for 2 years because of my job. So happy it's no longer the case. Back to C++ and no more enforced OOP. Well, I've got good news for you. You don't have to do Unity with OOP. You absolutely don't. What you need to do is just have the courage to do it. And be in an environment where people are not going to immediately, it's like, it's like you because you can. And in fact, one of the things, there are some rules that you can set up, and one of them that I like is never make all of your classes static unless there's an absolute reason why they shouldn't be, which is kind of the opposite way to object-oriented programming approaches, where the static class is treated as something of an abomination. It's quite funny. Need to show you it's time to do gravity. Exactly. Yeah, the way of doing, but the problem with Java, I tell you the story about Java. Java is basically was embraced by academia because it's easy to teach, because there's an IDE, and you just tell the IDE you want and boom, there it is, and it creates it for you. So I did a little bit of Java that way. It was a nightmare. I just couldn't abide it anymore. It's like, it's avoiding programming again. Let's get the IDE to program for us. And then always, there's no reason why you need to have a pattern in Java of always using an accessor or a property in C#. And there are some good reasons for using them, But what I like about C# is the fact that you can delay that decision. This is for me one of my favorite things about C# is that it does provide the opportunity to create that abstraction, but you do not have to choose ahead of time. Now maybe that's also true with Java, I don't know. But everybody who programs in Java uses the IDE and it slaps a flipping accessor function around everything and just does it. Just, you know, it's like, well, why is it not in the language then? You know, it's all a bit shame. Anyway, I'm off topic. I better get back to this. So what I need to do, oh hang on, with Java at the moment I constantly feel like I'm trying to learn a third-party library of tools that I could have made myself if and when needed. Yeah, you know, it's not a programming language. It's not treated as a programming language anymore. It's treated as a scripting environment. It's quite sad. No, they're wrong. I tell you, yeah. Oh no, they're wrong. Asynchronous. Static is not a code smell. I'll tell you what a code smell is. Code smell is any use of an interface. That's a code smell. Any use of inheritance. That's a code smell. Sometimes your code has to smell. There's nothing wrong with it. It's that, you know, like a good cheese. Sometimes there is a requirement for some smell. You just, and after all, you know, if life without smell, what is that? I mean, that's just like tragedy, right? But seriously, statics, no smell. None at all. Because the wonderful thing about statics is they are globally addressable without any fuss. There is only one instance, and guaranteed to be only one instance. There can never be two instances of a static class. And if you don't need more than one instance of a class, there is no good reason not to make it static. And most of the classes in most of the code bases that exist in most of the world only have one instance. It's the most common example, is one instance. So of course, in object-oriented programming, they make that one instance by that most laughable of things. You know what I'm going to say, don't you? The singleton. Yeah. The singleton, which is a non-static class behaving like a static class when you could have just made a static class. What a world we live in, eh? Anyway, big digression, but let's get on to, so we've got a name. Naming things is important, right? It is important. We're going to give a name to this. And so I've been digressing. All this time I've been thinking about what to call it. We need a module, right, that is going to do gravity. But I really don't want it to just have a generic verb. Because that pattern, gravity is a noun. And so you see this pattern a lot in object-oriented programming. And I'm just making a standard, a point here. It's like, do gravity. You know, it's like, do alert. You know, it's almost as bad as stay alert. It's do gravity. It's like, what do? No. Do gravitation. Implement. That's a verb. But is there a verb for gravity? A verb for doing gravity. I want a word. Is there one? Because if there was one, that would be perfect, wouldn't it? A verb that means doing gravity. Because of course there's so many. You could think of gravity doer. No, that's gravity doers 2 nouns. You can't say a doer. You do. This is it. I mean, you know, the warped brain. Fall. I thought you said fail there, but it's fall. That's possibly to fall. A verb. A verb spelled with an E. A verb that means to do gravity. Fall. The noun gravity. I don't want a noun. Is there a verb? No. Is there a verb? Attraction. Attract. This is hard. Pull. Attract. To attract. That's a verb. I'll accept attraction. Attract. See, I went and turned it into a noun again. Attraction. We all value our privacy. Click to accept. This is like. See, but now I've been witnesses. It's like, what do we do? Every single time I go and open a page now, it's click on this. It's whatever. Gravitate. Oh, gravitate. Thank you. Let's just, yes, that's what I was looking for. This is all part of trying to repair a broken mind, if you don't mind. Gravitative. Gravitate, please. Gravitate. To move in response to the force of gravity. You did it. You found the verb. Physics, to move under the influence of gravity. Oh, I'm loving this. Thank you so much. Yeah, there should be a there should be a thing that you know, law enforcement in an impractical way. It's a kind of a for that we wouldn't be able to function if we had to read this every time it popped up, and so therefore it's a form of coercion, and therefore every time I click on one of those things it doesn't mean anything. You know, I'm sure there'll be a legal case at some point about that. But anyway. Gravitate. And then, of course, because I'm so damaged by decades of object-orientated, I couldn't help myself there. My first thought was to turn it into a gravitator. I don't know, I found that funny. I'm sorry. I just found it it's hilarious. You go through all that effort to try and find a verb that means to perform gravity and then turn it into a noun again. The gravitator. You could actually call it the grand gravitator. I love it. The grand gravitator. There is a kind of halfway house. We could call it gravitation, and I think I'll have to use that gravitation, which is actually suggesting an activity, and it's somewhere it's you can hold it in your mind as it is a concept. It's a concept of gravitation, the gravitationator. Yes, exactly. The gravitation coordinator, the gravitation manager. It's like, yeah, gravitation is being decided. So what I do now, after having spent an eternity trying to figure out what to call this, I'm going to create the big moment here. Hey, Nested Madness, how you doing? I'm going to good to see you again. I'm going to create a new class. But I'm going to start following my rules because I've had enough. I mean, we've seen the old way. No, I'm switching full on now. I'm creating a class and I'm going to call it not the grand gravitator, but gravitation. But then, of course, as soon as I've done that, Unity, because I did it in here, has gone and said gravitation. It's a mono behavior. No, it isn't. There is only one gravitation in my thing. I have no reason. I'm not anticipating needing multiple gravitations. And it turns out that if that was to change, it's not actually that hard to change it. You know, you just okay. Gravitation. No, the gravitation executor. No, okay. Gravitate. Right. So this is now a static class. There's going to be a static class called gravitation, and it's going to do gravitation. Now, the next question you might ask is, well, that's fine. Well, how's it going to access things, and how's it going to get called? And that's a troubling thing, because the fact that it's no longer a mono behavior, it means that I'm not. How am I going to get this thing called? So there are actually other options for this open now with Unity that you can. And I'm going to see if I can do that. Public void do gravity. Yeah, no, that would be the function would be called gravitate. Manage gravity. Take gravity seriously. What am I going to do? I'm going to just look up something, because this is it. I really hate the fact that if I'm going to have something called every game loop, I need to have it called from some object in the scene. Wouldn't it be nice if I could hook in to the main game loop without having to go through an object? That's so call back every frame Unity. I suspect there may be an attribute. They've improved this in recent versions of Unity. These for me are the big improvements that I really care about. Gravity event listener. Did you see that all the problem with object-oriented programming pretty much stems from trying to name everything in nouns? Gravity event listener, and then you might have more than one kind of gravity event listener, and so then you would have a gravity event listener factory. Just shoot me, please. So I wonder, is there a callback? Please, I'd love there to be a callback. Attribute callback every frame Unity. See, there's this on-post render that's part of mono behavior. That's out. Right, Unity callbacks. It's so difficult. It's difficult to get a clear answer on this. Because I must be the only person who's looking for it. It's like full or multiple scripts. Unity events So, where's the list of Unity events? Abstract Gravity Manager, it extends interaction, implements force. Yeah, yeah, exactly. Shut it. List of all Unity callbacks. List of all Unity attributed events. Main loop Unity callback. I mean, all I want is something that gets called when I, you know. It's really annoying because I don't want to have to add another flipping manager just to call. This is, I'm spending a bit of time with this because this is a perennial problem, is that you actually want to have some module that gets called every game loop, but doesn't need to be an object in the scene. There's no good reason for it to be. Oh yes, thanks, that's better, Mycon, because force, it is both a noun and a verb. But now that you called it a force handler, there's no ambiguity and it's 100% a noun. So, no. Alright, all Unity attributes. Where are they? Can I have them? Oh, Summary of Unity's attributes. This is from 2014. You can't. That's sad. They maybe eventually they'll change that, but is there a Unity event called every frame? It's very telling that there isn't. Very telling. It means that this isn't a natural thought, and really doesn't. Now, I do look for this from time to time, but I think it hasn't. I think it's. Okay, I'm about to give up on this. Oh, execution order of event functions, Unity. I could. Every Friday. On application pause. This is called at the end of a frame where pause is detected. No. Fixed update, fixed late update, late update, late update, rendering. On pre-cull, on become visible, on render yield. No, there isn't. And this is really annoying. So what I have to do is create a totally pointless thing. It's a pattern I've done many times, so I'm just going to do that. And this is going to be called something. I call it different things different times depending on mood, but this is going to be called master. This master thing is not a static class because it has to be a mono behavior. So even though I've implemented strict Dino coding standard here, my thing states that you should use non-static classes when there's a good reason. The next thing you do is you get rid of that, and we'll carry on from here. Now the next thing is that on the awake function, which this gets called before start, we do this, and then I'm actually making a singleton. I know I die a little inside every time I do this, but even though I really dislike singletons, this is one of those situations where the architecture forces it upon me. It doesn't mean that there's any real validity to the pattern of the singleton. It just means that I have to hack something that happens to have a name. There's an abomination that happens to have a name because of Unity's architecture. If Unity just provided an event that was called every frame, you could be cynical and say they don't provide that because then everyone would start using it. I don't know. But anyway, this is what I have to do instead, simply because that doesn't exist. Oh, hang on. Yeah. Okay, so what I need to do now is with the master mono behavior, I'm going to create a public static variable which I always call underscore. Now this, what do you mean? Look, I have to do this all the time, and I hate typing instance all the time. It doesn't make sense. It makes the code unreadable. It's I use a single underscore variable in my personal code. Anyway, and where I get away with it, I use a single underscore variable to mean the single instance of a class, and so that this is not set to anything. So it needs to be called master. So you get this pattern: master, public static master underscore, and then in the awake we do if the underscore is equal null. If the underscore is equal null, then it means that we set the underscore to this, right? Else, and we also do don't destroy on load game object. So it does two things. First of all, it sets the static reference, and then it also says don't destroy this object on load. So now this thing will exist all the time and never need to be reloaded again. When you load a new scene, it stays in, right? So all that's fine. And then, but if it already exists, then you do destroy game object. So by a very simple little pattern, and we should return after that just to be sure in case there's other initialization I'll put in here later. So by doing this, this object there'll only ever be one version of this object, and I can have it enter into my into Unity at any time. So I could have this attached to a master object in any scene, where I load that scene separately by itself. Often you need to do that when you hit play in the editor and so on. You don't want, right? You don't to have to go through previous scenes. You just want it to work. So you can just put this in any of the scenes, but if it's already been loaded previously, it just silently removes itself. And so this is my favorite pattern for dealing with a manager. And so I can just go and do here, create a prefab. No, here, and do create an empty object. And then I'm going to call it master. And then I'm going to put the master script on master and then drag that back. So I've created a prefab called master. It's a prefab called master for an object called master that contains a script called master. All of this, and then all of that there, all of this just to get around the fact that they don't have a hook into the main loop of Unity. But once you've done that, with the proviso that all scenes have this, you're okay. Master section, yes. Let's just save that, right? And I hit play, and what happens? Right, so now we've got nothing. I mean, I've done all that and it's not, but I should be able to now have a call that's done every frame. But we're not quite done yet because there's still more pitfalls. Let me just, I have a button in my editor, a program my editor, to do this automatically. So I can just hit a button and it puts a login with the line and file. Now I know you get the line and file, but it's more easy to see it this way. So this, very often I need to do temporary logging and it just saves me typing. So let me hit play. Now I can see that this line 17 here is being called every frame. So that's fine. Now, really, using Unity is all about nailing stuff down, so that, you know, and the problem here is this isn't nailed down because Unity for some reason decided not to have a deterministic order of execution of scripts. This is a real mistake because it's the biggest cause of breakages of a game when you make a build or when you move on to a different platform, and it comes from the script execution order, as you see in here. There is this thing called default time, which just basically means random. Why they didn't sort all of the scripts in the default time section in alphabetical order, I have no idea. I mean, it surely wouldn't be hard to do that. It's probably a line of code. Now, if they did that, then you would have a deterministic order of execution that wouldn't change between builds, between platforms, and then you would be sure that if it worked on one platform, it wasn't going to fail on another platform because of script execution order. And they have this stupid thing here, and it is stupid. It's just like, it's something that could be handled by a text file much more elegantly than this drag around thing, especially when you end up with a very large number of files in here. This pop-up, oh, I mean, look at that. So, yeah, and then you have to, you know, find it in the list, and then you scroll, but it's a pop-up, so there isn't usually an actual scroll bar here. So it's really ill thought through. I have a solution that I found, which I really like, which I will show you in a minute, because I hate using this with a passion. It's just useless. Yes, it is absurdly bad, but the thing is, it's absurdly critical. So this would be an example of something totally, utterly serious and critical that can cause your build to break on the last day before you have to submit. And yeah, it's got a UI associated with it that's appalling. Well, it's an interesting thought that you bring up. I mean, wouldn't multi-threading break that? I would argue that if that was the case, then there should be an option to say this file can be managed by the job system in terms of order of execution. So that is a fair point, but there would be a good way of doing that, to mark it in that way, and then at least it's under your control, with the default being that everything is nailed down, you know. Anyway, so what is the solution? I need to look it up because I don't remember it, but there's an attribute that allows you to, I only discovered this a few months ago, attribute execution order unity. So script script. Right, undocumented, of course. I mean, why? If you notice, it's fascinating how sometimes you get these little nooks and crannies of a project, of a system like this, and you go, every turn that you take, there's some kind of little block. It's like a mental block. It's really weird because there is one, but it's undocumented. Default execution order. So what I want to do is make sure that this is executed before everything else. So it's still a bit hacky, but I'll take it as the best solution I can have at this time to a difficult problem that shouldn't be difficult at all, because it seems absolutely fundamental to me that you should be able to have some part of your game code that you guarantee is executed before everything else in a robust way. Anyway, that has compiled. Was it? Okay, well, it works. I mean, we can see though, is it been around this long? Let's have a look and see if it's documented. It was 2018, not 2008. They joined in 2008. This was 2018. Look at this. It's still not documented. What is it with that? Okay, so now that I've got that, I have myself an update, and so probably would be nice for me to create, because I'm trying to push this to static as much as possible because there's only one of these things. So this is public static event what shall I call it? Execute is a verb, because I'm trying to push my program to use verbs as much as possible. Not executor, execute. And so I should be able to do, oh gosh, I don't use events that often, so I'm just trying to remember there's execute dot, I can't remember now, call an event unity or C#, invoke, that was it. So we'll see if this works, but this little pattern here should provide for me the hook that I want into the main loop of the thing. I'm overrunning here. I normally do 2 hours, but I'm having fun. I'll carry on. So yeah, it doesn't like that. I think I've done it wrong. It says invoke. Oh, because it's a Unity event. It is invoke. Okay, let me just see if this is. I can call execute. I'll try it. No, there is no definition for execute. You can? It cannot be used like a method. So let me just see. It's a bit of a weird syntax. It confounds me. It's a public event because event is lowercase. Hang on, C#. Public event handler, threshold reached. Oh, come on, I've used them before, but okay, I'm just not familiar with it, so let's try. But I should be more familiar with these. So I'll do public delegate void my event handler if this is not lying to me. Public delegate void. So we say execute handler. So we can do public delegate void execute handler string. Don't need anything in there. public delegate void execute handler, and then I should be able to create, that's the delegate definition. Then we need to actually have the event public static event execute handler execute. It's not a very memorable kind of API, syntax. I don't think that actually created an error, so that's cool. So that's fine. And then what I do is add to the execute. Oh, yeah, execute just as you said. So now that, so my problem was that I need to define a delegate that then will be used by, yeah, makes sense. I have to define the delegate, and then I say public static event, and I specify the type of the delegate, like a function pointer, right? And then execute. So that actually should work. Cool. So what I do now, after all of this, is I wanted to go back to gravitation, and in here, the next problem is that, you know, this is all well and good as I am trying to, you know, implement the rule of let's not have a static, let's make everything static, and I am fighting Unity here because I'm using Unity in a way that it doesn't want me to use it. But basically I need to have this initialize itself now. And when it initializes itself, it has to register the handler in here. And I think there is a way to get that, believe it or not, even though there isn't, for initialization, even though there isn't a way to get the call in the loop, there is an initialization which is runtime initialize on load method attribute, and so it works like this, and this is actually pretty cool. Who's become an event manager? Stop breaking my heart. And initialize on load method, and I can pass a load type into this. And the type of initialization I want is this, and I can see after the scene has loaded. Okay, yeah, I think the default of this, let's just check, is after the awake method. So it's a bit weird, but when you do this, basically this is actually really quite useful. I don't need to put that in actually, because what Unity will do if you put this attribute on there is it will call this after all the awakes. So all the awakes are called of all of your objects. And then after that, any static methods that have this attribute, right? any method that's defined, any static method that has this attribute will get called after awake, which then allows us to initialize a static object. So I only discovered this recently. This is good. This I like, because now it means that this gets called after our master class has done. Maybe I should call it mastery. Anyway, after that is done. So I can then call this, I can register a method with this now, and so that's what I'm going to do, I hope. And I have master dot underscore, get this instance here, and then execute plus equal update. And then in here I can do void update, and this will get called every frame. Now I'm just wondering about what happens if, you know, this is every time. Will I get multiples of these? We'll find out. I won't worry about that just yet. Anyway, let's put this in as line 12 gravitation.cs, and oh, cannot, of course not. I mean, can't you just let me off? Let me off. It's like it's a static class. Cannot be accessed. Use it with a public static master. Oh, because it's I don't even need to do that because it's a static class. Oh, that is cute. Actually, I can just do this. Master execute physical update. And then, if we're lucky, look at that. Gravitation line 12 has been called every frame. I have now got a static class that has an update. And it's worth it. It's you know, it looks like a bit of a pain, but it is actually worth doing, because in this case I have my gravitation class is something that should not be it's not an object. I don't want it attached to it. I suppose I could have done that. I could also have just followed the pattern of master and just made gravitation an object in the scene, but somehow this feels a little more programmy. It's more like I'm being a programmer now. I think that's important. So where do we go from here? Having created this, we can go back into embody. Oh, which one it was? This one. There we go. So this is very little code here, but it was, as you remember, it was going between. There's basically this component was on the two objects. Well, now there's going to be no components. That's the other advantage. I'm not going to have to add any components because it's going to get handled by gravitation. Well, of course, it needs to know a list of the different objects, and I can do that by scanning the scene for objects. So, you know, maybe what we can do is put a tag them. If I add a tag in here, God, click. Tag is going to be body. I'll call it body. So both of these, if it will let me select both of them, please, thank you. This is now tagged body. Let me save this. Right. So what I want to do is find all objects with body in the scene. So that is game object dot find objects with tag, if I remember rightly, body. Now this is not a particularly efficient function, but I'm only going to call this once. Requires music. Let's see, what do we have on Radio Radion now? Are you there? How?
This is Radio Radian. If you want to contribute to this new creative community radio station, click on the link at radioradian.com.
It's funny that, that's totally by luck, that only says something once every 15 minutes, but wow, synchronicity, what can I say? That was the end of the Bob Dylan track. Anyway, let's take a look. Guest star. A Quentin Martin production. Let's see what we can do here. Oh, for each var x in body. So this is finding all the objects in the scene that have the tag body, and I like to test as I go. I'm just going to check that and see if it finds them. Oh, it doesn't like this. Hang on, does not contain. Okay. Find objects. Let's do a web search for Unity. Find game object. Oh, so close. Find game objects with tags. Alright. And what do we have? If I hit play, look at that. That worked. It found them. So when this initializes itself, it searches the scene for all the game objects with body in there. And that's fine. What do I do with it? I create a list. Static list game object list equals new lit new list game object. So on the initialize low method, I say list dot add x, and I have all of those objects in a list, which is quite good. Of course, I could get a bit better than that and do. No, I don't need to, because I'm going to work directly with those game objects. So at this point, I can go through each of the objects, and I could do a for each, but I'm not going to. I'm going to use this. There is a reason. The reason is because there's an optimization to avoid having two bodies executing twice. That is, this attracts this one and this attracts that one. You do both together, but this means that you don't want the reverse pairing ever to occur. And this is a standard pattern that I commonly use. Anyway, I'm going to go through this list, and I need to pick out the game object A equals list I, and let's just print that out. I'm going to test this and see if that works. I'm just like testing as I go, and we can see that every frame it's calling the 0 and the 1. Okay, so the next thing is that I want to check this against all the others in the list, because I have to check all. We're going to the n body problem. You need to check everybody against everybody in the scene. So the good way to do this is to set up a second loop. But instead of doing it like this, where I go from j equals 0 to the count, then I'm actually going to do, like if I have 10 objects, I do 10 loops and 10 loops and I check 100 times, then I'm going to check pair backwards and forwards, 37 with 48 and then 48 with 37 later. But if you do this instead, you start checking the second loop is initialized, right, from I plus 1. I don't need to start from I, because then you'd be comparing, it would be checking against itself, right? So this also gets around that problem. You don't need to filter that one out. But if you do that, that works. That's all you need to do. You start from I plus 1, and now inside here you will never get a duplicate pairing. So in there I can say game object b equals list j, and so now I have a and b. I want to create, do this code. Now one of the little issues I've got that I need to figure out what to do with is, where do I store these properties, such as the mass and the velocity and so on. So the object-orientated way is to then think of these as being all part of the same object. The non-object orientated way of doing it is to think about a list of masses, a list of velocities, and so on. So that's the data orientated way. I'm going to just go with the data orientated way for the minute, because also I want to do some experimenting with the burst compiler, which I've not worked with before. It's sort of like that lends itself better, that works better if you've just got like a list of positions. I don't have a list of positions at the moment because I'm actually using the positions of the actual objects. I'll have to look at that maybe, but I could have a list of velocities and a list of masses. It's really simple at the moment. So it's so simple that I might as well just do this. Let's create a list of vector 3's velocity. People often, from an object-orientated background, don't ever consider this way. But this was the way we used to do it all the time. I mean, it's sort of... especially when you're writing in even in assembler or whatever, you would do this. You would create a list of, instead of having a list of objects, you have a list of properties, if you see what I mean. So I've got now a list of vector 3's and a list of floats. Well, this list of floats would be mass. Now I'm totally outside the domain of using the inspector. So in terms of prototyping, that's a disadvantage, because now I lose the ability to edit things in the inspector. So what I think I'll do is I'll just put a pin in that for now. I can always come back to that, but I'll do a kind of hybrid approach. If we look at this, we had an object called nBody, right? And I'm going to just keep that as is. I'm going to keep the mass. I'm not going to have the other. The other we don't need anymore because that's being handled by the other. We're going to have the velocity vector. That I do need. This fixed update thing, this just goes away. Why is that shortcut? Oh, I don't have it set up here. Okay. Hash if false. I've just got rid of that. So what I actually have now is I've got this other stuff that really should be in a different file, but I'm leaving it there for now. So what I've got is basically just a mass and a velocity, and I'm going to use that as is. And this will allow me to edit the properties of these as I did before. So you can kind of mix and match the approach. What this means that is when I get to this is now a game object. Yeah, I'm going to change this a little. We're going to actually make this a list of n bodies instead. And then when I'm doing this add, I have to do x.get opponent in body, like so. So then this becomes much easier to deal with. N body A, n body B, and let's just make sure this compiles. It does compile, which is great. And then in here is where we're going to do this finally. Finally, we get here. Calculate gravitation. Doing my best to avoid naked nouns. A naked noun, right? So n body b equal list float g. I'm going to keep all that the same, but I need to change this other position. Well, this all works because this n body is derived from one behavior, so maybe this is probably going to be an error. There must be other doesn't exist. Of course other doesn't exist because I called them A and B now. So this becomes B dot position minus A dot position, and use local variable A before it is declared. So, oh yeah, because I have a. Alright, so I'll call these B1 and B2 then instead. Body 1 and body 2. Let's try again. Next error is other doesn't exist. That's right, because this would be b.mass. So the next error is b does not, b2 mass, right? Then we here math doesn't exist. System.math, right? Next one, velocity doesn't exist. That's because this is now for the acceleration of b1 plus b1 dot velocity plus our acceleration. But there is a variation I have to make here now because I need to know the acceleration for both objects, because I'm going to calculate the forces on both objects at the same time. So that's the acceleration on object 1, and acceleration on object 2 would be this. You see it's mirroring the two. So that calculates those. We can then say the normal is the same for both. The acceleration for 1 we could call A1, the acceleration for 2 we could call A2 is equal A n times A1, n times A2. The A1 velocity is then equal to is plus equal A1, and the B1 velocity is minus equal B2 because of the A2, sorry, because the forces and therefore accelerations are in opposite directions. So this, if this works, this will go through and for every body against every other body calculate gravitation, setting, changing the velocity of the objects, and doing all of this. Go back to the problem that I had, which was the fact that the calculation was changing the positions of the objects during the course of the calculation, which is an error. here it's going to calculate the velocities changes, but not the positions. And once that is finished, then I need to do another pass where I go through. I go through and I have to, for each body, I have to do b1 dot position plus equal b1 dot velocity, and then in theory that does it. We'll see now. We've got errors. We've got one error. I'm just trying to work out what it doesn't like about that. A1. Oh, A1 is actually, that should be B1 and this should be B2. That's better. Right, we'll try again. And here, what have we got? No errors, it was just one error. Not bad. We go and hit play, and probably all hell breaks loose. Whoa! Okay, actually that wasn't too bad. Wait a minute, missing reference exception. The body, the object of type mbody has been destroyed, but you're still trying to access it. So this was a thing I was a little bit concerned about, is that I've registered this execute on the start, but because I am using Unity's special super fast thing where it doesn't reload the assemblies, this does not get removed when you hit play again, and so it's trying to access objects that were destroyed previously. Now the way to get around that after scene load, before scene load, what I want to do is unregister this, but it needs to be unregistered when, this is where I hit the problem with this fancy new thing, fast startup thing. I suppose I can clear, surely I must be able to clear So this is an interesting question, is how do you clear all the events? I need to see if there is a way of doing that. I can force a clear in the awake. Clear all events C#. There's no answer. How do you, oh gosh, I can't find it. How do I remove all event handlers? I can't believe it, there's no way of doing it. Okay, so I've got myself a little issue with that because I need to remove these registered events. There's the reason not to use the event system. I could have used my own. See, I normally roll my own. I think I've been here before. You do this, and then it's like, oh, I need it to clear any existing events. Or we should dispose. I'll try. What is the best practice for cleaning up? Okay, I could try using a dispose. Oh, I see. So, aha. No. No, that doesn't really get me it. There's no way of execute handler. I mean, I don't know if that works. I'll just try that. See, it's like that. You can't. Oh, execute. No, that doesn't work. You can't do that. So this is pretty awful. I don't have the flexibility that I really want. So what I'm going to do is just not use, which is, let's see, wait, I've been here before. I'm just not going to use Unity's event thing. It's just Unity, C#'s event thing. I could use Unity's, I suppose. You know what? No, let's not bother with it. I'll just do this instead. Let's define a list of actions that take nothing. It's just a list of actions. Execute equals new list action. Okay, and that's going to be private. Then I'm going to do a public void add handler, which takes an action, and this is going to simply do execute.add the action. This is actually cleaner and makes a lot more sense and less to go wrong. Here we can do for each var x in execute list. I'll just call it that. In execute list, and we just do x. Done. And in the awake function, I just do this, and I can actually get rid of the initializer here. No, so those are good questions. No, I think in this case I'm just implementing it with a list. So publicly, all that you have is add handler, and with this implementation, the order of execution will be the order in which they're added. If I wanted to have something fancier, I could do that. Yeah, you know, it would. But the thing is, I don't need to decide that now. If the order of execution is dependent on the order in which they're added, that is deterministic in my book, and that's all that matters. If have it deterministic, but it doesn't really matter beyond that. If I need, what I would do if I needed different execution groups, is I would define execution groups. So I would say maybe you pass in an integer, and that execution group 10. Anything in 10 will be executed in the order they were added. Otherwise, it goes through the execution groups in numerical order, if that makes sense. That just made my head hurt, Icon. I saw that one. You know, this is easier, and there's nothing wrong with it. It's just like, yeah, you go through all the action, you execute them, and see what's going on. There's no weirdness. Probably be an error because I need to. What's this? Public void add handler action because I need to say system. Next error is master does not contain something called execute. That's correct because now our public static void add handler. And I can also just make that static, and I can just add a handler. And I don't need to worry about it anymore. Let's try this. I've still got that error there, but I think it will go away now. Nope. No, it's still something it doesn't like. Let's have a look at the stack trace. So this was from, yeah, when it called that. Okay. No, it's possible that this is a different error, but this is because it's accessing objects which have not been reinitialized. So the question here is, does this runtime method load ever get called again? This could be due to yeah, it did get called again. Yeah, this is a separate issue. When I'm adding to the list, I need to initialize the list first, because basically it was this didn't get reset. Now normally it would, but because of the because of the fact I'm using the fast start facility, which is a new thing and really saves a lot of time, but it does mean that you have to take care of little things like this, because it's not between hitting, every time you hit play, it's remembered stuff. So I'm quite happy to work around that. Two reasons. One is that it allows me to do fast starting, but it also imposes a discipline that reduces the risk of problems later. Let's see if this is going to work. No, I still have a problem. I didn't save it. Let's try again. As you can see, I'm catching. This is something that would catch me out if I was working on a game later. It's inevitable. It's the kind of thing that causes problems. So now I've been forced to fix it early. Now, this is all good. Actually, we're getting there. The thing is, I have gravities working in the wrong direction. So let me just reverse the polarity of the flux capacitor, and we should get. Come on, you can do it. Woo! And hopefully, now that I've done this, we have stability, because I'm pretty sure that instability that we had before was due to the fact that it was moving, the objects were moving while the calculation was in progress. And as you can see here, that is a fairly good impression of stability, quite pleasing. What's great about this is that now I can go further. I can add more, because we do have a full n-body simulation now. This is where it gets exciting. What will happen then, you've got this thing's working fine, but what happens if I duplicate an object? The object I am duplicating has also a mass of 10, so let's turn it back to a mass of 1. It's going to be positioned, say, here, and with an initial velocity on the x-axis 0.01. Three. This is so fun. This is it's one of my favorite simulations. Look at this. This is brilliant. I mean, to have one that was that stable for that long. Let's actually try that again. I mean, it's actually quite complicated, that one. Look at that. Is that cool or what? And we can just add more. I mean, there we go. Here's another one, also moving in the same initial conditions. Well, yeah, that's more typical of what you get. Is things just. Yeah, this is looking good. This is looking correct. Correct. You get the pattern that's happening here is that oh no, they're not really colliding. What's happening is that they're getting very close, and then the gravitational attraction is causing a kind of slingshot effect. They aren't colliding. If they were to actually collide, it would change the behavior. So this is sort of like the ideal case. Yes, it is 3D. That's the thing. It's like, I've been doing this in 2D, right? But in actual fact, it's 3D. We even have shadows. Look. So let's turn off. Let's just go back to the 3. The general pattern is the more that you put in, the more unstable it becomes. The only reason why you have complex systems of things orbiting each other that are stable with the solar system is because it's a pattern where you have something really big around which something smaller is orbiting, and then you can have something orbiting around that, or you can have something orbiting the moon that orbits the Earth, that orbits the Sun. These are stable configurations because in the end the interaction between the spacecraft orbiting the moon and the Sun is very small, or between the moon and the Sun is very small, so that you can think of them as actually small pairs of orbiting systems. The reason why we've ended up with the solar system only exhibiting such stability is because all the instability, by definition, it throws things out. So it's quite possible at one time it was much more chaotic, but stuff will have been getting thrown away from the solar system, or crashing into the Sun, or whatever. So it's quite natural that what you're left with is a stable configuration, because everything that was unstable got removed. So that's cool, but it is 3D. So if I take this and do a little tiny lift on there, everything will change. I was expecting to see more of a change than that. There we go, off of the elliptic. And, whoa. I love it. I love it. This is. And it's such a simple simulation because in the end, it's just a few. It really is just a few lines of code. So I'm going to just see if I can pull this thing down a bit, and you can see. Fact that it's 3D, it just works. You just do vector math, and you can. The 2D is the same as the 3D. It's not practice. It's not appreciably more complicated. Can you make it 1D? No. What's happening? Have they kind of entered a? Yeah, it was. I remember doing this for I think on the BBC Micro. It was. Yeah, it's actually quite easy to do it in 11. You can do it in any number of dimensions, more than one. I'm just thinking, could you do it in one? I suppose you could do it in one, yeah, but it wouldn't be very interesting indeed. Look at that. And eventually, that was a really long one, and eventually it threw these guys out. So, yeah, let's put more in, but have a velocity of 0. This is the n-body problem, which is you're solving it for any number of bodies, but the thing to remember is that the number of calculations goes up approximately to the square of the number of bodies. Where's the heavy one? There, that's the heavy one, which I'm going to put a bit higher, like that. And so it's computationally very expensive. Yeah, I could do that, absolutely. That's something we can look at next time. Oh, we got not a number, not number, not number, which means that I've got two. I had two objects on the top of each other. Look, and this is typically what you get when you go and have a lot of them, as you can see, and they all fly off, and then so one way to try and make it more stable is that you find that big heavy object and you make it even bigger mass. Shoot, where are you? There it is. And of course they're all they're all hitting each other because they're all attracted to each other, so I may have to spread them out a bit. It's just right down there. Right. So try and achieve stability in 3D by experimentation is quite tricky, indeed. So take this further. Well, I don't know. I could just generate a whole bunch of masses at random, I suppose. Yeah, how would I do that? I think that's something I will do for next time. How about if I drag this around, right? Or we could go duplicate all of these. Duplicate all of these, please. Thank you. And see what happens. If you get these simulations big enough, then you can start creating galaxies, but I don't have time to sort of do that right now. But what we can do is just look on YouTube at these simulations. They're obviously tube n-body simulation. This is with a huge number of bodies, 131,000 bodies. This is, oh, hang on. This is a crazy amount and requires some serious serious work. This is using CUDA, OpenCL, and it's actually a master's thesis, the guy's master's thesis. You can take this stuff to ridiculous extremes, but here is an n-body simulation, and it's playing back at 16 time capture speed. So the simulation is cheating a little. The simulation is 16 times far. This is 16 times faster than the actual simulation. But you can see how there's a kind of explosion. It's running for 4 minutes. And so when you've got enough of these, sort of patterns start forming. Oh, you could zoom in. Look at this. Oh, look, it's like galaxies. But this is basically exactly the same as what I've just been showing you, but with the very large number of bodies. Look, the universe is collapsing. But one of the things you're not seeing here are like spiral galaxies at the moment. They've not really kind of formed. I remember trying to get that effect. Not really succeeding. But the last time I tried to do that was quite a long time ago when computers were a lot less powerful. But look at that. It's fascinating. You get strands. I had often wondered about that. So if you get strands of gravity, It's really cool. The thing to realise is that there are very few collisions really going on. Yeah, I don't know. I don't know what the cause of the spiral is. I suppose to do it properly, yeah, to do it properly, you would have to put in quantum mechanics. You have to put in relativity into the thing. But what I think is really cool here is how you're getting he's getting clumps of stuff. Oh, that's really interesting. So if you don't optimize it and you're trying to do 130,000 in the n-body problem, that is 17 billion. In theory, 17 billion of those calculations every time step, and so that's pretty huge. That's why this is running 16 times the actual speed. It's like even if you throw everything you can at it, and they use supercomputers to do these kinds of simulations. There we are, 17 billion body-to-body interactions per iteration, 131,000 bodies. You had a velocity damping. Oh, where is it? Velocity damping, softening factor, hollow sphere on sphere initial. Okay. Simulated, rendered and captured on GTX 780. This is from 5 years ago. 175 milliseconds per iteration. That's staggering. You think how many calculations are being done there? 175 milliseconds to do 7 billion calculations. And he's given code as well, if you're interested. Fascinating. Anyway, I hope you found that of interest. There was a lot about Unity and programming as opposed to the maths. The maths part is actually quite simple, really. But thanks for watching. I had an extended program tonight. On Mondays, 9 o'clock, I like to do a maths workshop, and on Fridays at 8 o'clock, I like to do some live jazz. So hopefully that will be happening this Friday. Thanks for tuning in.